like we've done in the past, linear regression and exponential. Let me write this down. When you go into spreadsheets, you put in the table. There's two options, at least what we've learned this year. Linear is when you press menu 4, 1, 3. And yesterday we learned for exponential, it's menu 4, 1, A. Okay. If it writes, it's not writing. There we go. Okay. What's going on? There we go. Okay. So here's the question. How do you know which one to use? Well, I'll tell you. You should be able to tell me if a table is linear or exponential. If you tell me which one it is, then if you tell me which one it is, then you can use menu 413 for linear or menu 418 for exponential. Okay? Now, this is stuff you already got. Linear is adding or subtracting by the same number, right? Let's look at this one. Is this adding or subtracting? Let's find out. So 20 down to 14 is what? 6. Okay, so minus 6. The question is, does it keep doing minus 6? So 14 down to 8, is that minus 6? Yes, okay. And then 8 down to 2? Okay, so do you think this is linear?
Yes.
Why? Because it's adding negative 6 each time. So you should be able to tell me, without a calculator, whether it's linear or exponential. Now, once you know it's linear, guess what you can do? Menu 413, type it in the spreadsheet, menu 413, get your equation. That's what we're going to do right now. So, let me pull it over here. The Cowboy Jams, you know? All right, so new document, don't save. Number 4 for spreadsheets. And this is what we did yesterday. For some reason you were absent. Okay, it's kind of a review of 3 weeks ago. What do we always put at the top? X and Y. And then in the table, we're going to put 1, 2, 3, 4 for the X. And then for the Y, 20, 14, 8, and 2. Okay. Now, we already know by looking at it and finding those differences that it is linear. So I'm going to press menu 4-1. Now remember, X has to be X and Y has to be Y. Don't hit cancel. Okay. Try that again. Menu 413 and hit OK, and there you go. Now, that's just information. Remember, the equation is y equals mx plus b. So y equals, what's m? Negative 6 x plus b, which is 26. Very good question. Hold on. So m and b is all I need because that's all it has in the equation. Now, let me remind you what r squared is. One in this situation. You want it to be as close to 1 as possible. Okay? This is kind of a clue that you picked the right thing. So if r squared is 1, you picked the right regression. Now, let's try this again. What if I picked the wrong one? What if I did menu 4-1a? Let's try it. Menu 4-1a, x is x, y is y. Now, what's the r squared here? 0.907. Now, 0.9 is close to 1 still, but it's not as close as 1. You know what I'm saying? So, theoretically, you could do both, see which r squared is closer, that's the right one. Okay? I don't know if that's faster, because that's a lot of buttons. But this is just a way to check whether it's good or not. Right? So, that's number 1. Let's try number 2 real quick. What's happening each time? So, do you think this is linear or exponential? Well, it doesn't matter what we think. We want to try to reason this out. So let's try adding each time to get from adding. Can we add? There we go. To get from 0.2 up to 1 is adding 0.8, 0.8. Are we adding 0.8 each time? From 1 up to 5 is 4. Those don't match. Is it linear? No, 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 no. So yeah, and since we only have 2 options, it's obviously exponential. In the future, though, you know, there's other functions, quadratic,
Cubic, quartic. No, we're going to. We're going to go over quadratic, which should have been algebra 1. Cubic and quartic will be, and logarithmic should be this year if we get to it. Which one? Quadratic. Supposed to. I know. So check it out. What is it multiplying by each time? Now, if you don't know what the multiplier is, it's a point two up to 1, and you remind it, you divide this thing each time, you get a ratio. Does that ratio the same? It's exponential. Everyone hear me say that? So let's divide these. 1 divided by 0.2. 1 divided by 0.2. I'm going to actually use my calculator to help me out here. 1 divided by 0.2 is 5. Okay, let's do the next one. 5 divided by 1 is 5. 25 divided by 5 is, what do you think? 5. Y'all with me? So again, so we can get our equation. This is what we did yesterday, literally, right? Number 4, x and y at the top, not r, y. Okay. Okay, plug in the data. Okay, and then 0.2, 1, 5, and 25. Since we know it's multiplying by 5 each time, it's exponential, I'm going to do menu for 1a for exponential. X must be x and y must be y. I have an equation of a times b to the power of x, and I have an a and a b. R squared is 1. Is that good? Okay, so let's write our equation. Y equals a times b to the x. What's a? And then parentheses to the power of x. Okay, good. Good. Now, let's say we goofed up and we didn't do exponential. I want you to see this. If I do menu 413, if I do linear every time, for some reason, because I'm confused, look at my r squared on this one. If I use the wrong one, 0.75 is a lot farther away from 1 than 1. Okay? So again, r squared is a helper. Say it again. It's basically like this. What a linear regression does is it gives you a best line, and your points are like looking like curved like this. So the line it's giving you is kind of like just going through the middle, but that's not the best thing. We need an exponential that goes through. So when r squared is less, not 1, that's when it's like not hitting all the points right. So, okay, now I mentioned this earlier, I think, but what you're going to do is, this assignment has mixed tables, just like the warm-up. You got to tell me is it linear or exponential, like the warm-up, and then give me the equation, like the warm-up. Then you 413, or hey, you got to tell me. Okay. If you finish this, you probably have something you can work on from that grid sheet. All right, I don't know what we're doing. All right, let's get started.